Good evening. We're just getting started. We'll be checking the sound and then we'll get underway. So just making sure that sound is coming through. There's usually a bit of a lag. Good evening. We're just getting started. We'll be checking the There we go. I think I'm happy with that. I think we're going pretty good. Just making sure that sound is coming through. There's usually a bit of a lag. Get ready to go as soon as it strikes. There we go. I think I'm happy with that. I think we're going pretty good. And yeah. All right, there we go. It's 7 p.m. and we'll continue on. Now, last night we were left with a problem. We're doing linear equations and we're looking at simultaneous equations. So a simultaneous linear equation gives us the point where two lines meet. And so what we do is we solve the simultaneous equation, which doesn't require us to draw it, but I just like to draw it, and that just sort of shows us how it all fits together, because that's what I like about maths, is that it all comes together. It all relates one to the other, to what we've learned previously and what we need to know moving forward. So, right, let's have a look at this one. So equation 1, we've got 2x plus 3y, we'll get them both written down, equals 31, is that correct? Yes. And then we've got 3x minus 2y equals 4. Now, what you find here is, this is equation 1, this is equation 2. They're both linear equations, as we can see, because we have just the single value of the x. It's x on its own, or to the power of 1. So that tells us it's linear. And what we could see, if we add those together, we won't eliminate anything. There will be no elimination. Like, if we added them, we'd get 5x plus y equals 35. Now, one of the things about an equation, remember the equal and the balance. So if you do the same thing to both sides, it doesn't change the equality. The equation is still true. So what we can do here is, if we say, for instance, multiply equation 1, if we multiply that by 2, you can see that 3y would become 6y. And then if we multiplied equation 2 by 3, the 2y here would become negative 6y, and the 2 would add together. And we've done the same thing to both. We've multiplied both sides of that equation by 2, so it hasn't changed. And the same with equation 2, except we've multiplied by 3. So let's see what we get. So we get 4x plus 6y equals 62. And then we get 9x minus 6y equals 12. Now let's add them. Add them together, we get 13x equals 74. 13x equals 74. Is that right? Just checking. 2, that's 4, 6, 62. And 9, 6, 12. And if we add them together, we get 74. And then we divide through by 13. Now, I don't think this is going to give me a whole number. 13. Okay, so that gives us x equals 74 over 13. Right, so let's see what 74 divided by 13 is. So it's 5. 74 divided by 13. 5 3s are 15. 5 1s are 5. That gives us 65. And 9/13 remainder. 5 and 9/13. Let's we'll do that on the calculator. So we get 74 divided by 13 equals 5.692. Now, the reason why you'll notice that I'm a little bit sort of apprehensive about this is because I thought that it would come up with a nice even number, but it hasn't. 5.692, and so let's now find out what y is. So we can, in equation 1, we can go 2 times 5.692, so we'll substitute equation 1. 2 times 5.692 plus 3y equals 31. And then we'll go 3y equals 31 minus, what we got here? What we've got there, 5.692. I'll multiply that by times 2. Times 2 equals 11.384. 11.383. I'm going to leave it at 11.384 because I've got a rounding problem there. Oh no, we'll make it 11.385. No, 11.384. Yeah, we've rounded it there. Equals, I'm I'm just going to go minus 31. So 19.616. That would be 19.616. I'm going just, yeah. Oops. 19.616 divide 3 by 3. And then we divide by 3. Divide 3. And we get 6.538. Oops. So I thought we were going to have a nice even number, but y equals 6.538. So intersection is at 5.692, 6.538. And you can see that's quite a complex answer there. So let's have a look at that. And so we'll go to ChatGPT, and I'll put in the bracket 5.692, 6.538, comma. Good on you. .692, we've got that one right, and 6.538. So it's done it all there. That's the ones there. It's pretty much did what I said there. Added them together. 5.692. Substituted that back in there. 6.538. Yes, and it said, would you need one that lead to a whole number? Yeah, well, that would be better, wouldn't it? But let's so we've got these two graphs here. Let's see what it looks like. There, we'll take the opportunity because we're working with straight line graphs. So let's just come back again. 2x plus 3y equals 31. What does that look like? So I think it's fair to say in most cases, in real life, yeah, the answers don't come out as whole numbers. We just keep it nice and simple like that to make it a bit easier to understand. So we want to put it into the form of y y equals mx plus c form. Okay, so we get 3y equals 31 minus 2x, and then we'll divide all that by 3, and that'll give us the graph y equals 10 and a third minus 2/3 x, which equals negative 2/3 x plus 10 and a third. I might just leave enough room down here for the other graph. So it's 3x minus 2y equals 4. So you can see here how by doing this we're practicing all our previous little skills that we had a look at. So quite important. Equals 4. So let's see, we've got 3x minus 4. So that's put the 4 on the other side, left the 3x where it is, and put the y on this side, 2y. Divide through by 2, and we get 3 over 2x minus 2 equals y. Now something that you'll see here, 3 over 2x, that's the slope, and you've got negative 2/3, which is the reciprocal, the negative reciprocal of this slope here. And what that tells me in this, that those graphs are at right angles to each other. The negative reciprocal. So if the slope is the negative reciprocal, so the reciprocal means it's turned upside down. So that's 2/3. Turn it upside down, 3 over 2. Change the sign. It's the negative reciprocal that means they're perpendicular, yeah, at 90 degrees. So let's try and draw these graphs here, or sketch them. So the first one, 10 and a third, so we'll put that, let's say that's about 10 and a third. Okay, and so we'll do a bit of work on that one, just down here. When y equals 0, we'll get 2/3 x equals 10 and a third. So we want to get x equals 10 and a third, which is 31 over 3 times, and we'll flip that over to divide fractions. You change to divide by multiply by the reciprocal, 3 over 2. So that equals 93 over 6. 93 over 6. Then you multiply the tops, multiply the bottoms, which is 6 goes into that once. Goes into that once. 3 over 6 goes into 35, and 3 6, which is 15 and a half. So when y equals 0, if that's 10, 15 and a half. That'll be the, And we can see that negative gradient, it's going down from left to right, so that was negative 2/3. Right, now 3 over 2x negative 2, so negative 2 is about there, and when y equals 0, 3 over 2 x equals 2. So x equals 2 times 2 over 3. Again, change the reciprocal, which is 4 over 3, which is 1 1/3. So we get negative 2 there, 1 1/3 there. And yeah, we can pretty much see that that's intersects pretty much a right angle, even just while sketching it there. So that's a right angle there, and that's our 2 points, which we said are, let's see, what did we say they were? 6.538 and this one down here 5.692. So yeah, there we can see there how it works. Again, a straight line. So we've done a whole heap of different examples there. We've done we started with a simultaneous equation, and we worked out where it the intersection of that, and then we showed that that was the intersection of the two straight lines. All of those are separate little entities on their own that would come in to the come into play in different questions sometimes in the test. Now let's see if we can do an easier one, and go to Chat GPT and say here yes please, and it should come up with a nice little simpler one for us, which will change the page. And so it's come up with 2x plus 3y equals 24. Is equation 1. And then it's come up with 3x minus 2y equals 1 as equation 2. And again, we can see if we multiply this one by 2, that will become 6y. And if we multiply this one by 3, that'll become negative 2y. Okay. So, yeah, let's do that. So we get 4x plus 6y equals 48. 9x minus 6y equals 3. Yep, and again, let's add those, and we get 13x equals 51. And I don't think that one's going to work either. ChatGPT's let us down again. It should be 52. For 13x to go into it. Let's see if we can get something better. I don't think that will have equal. I will have whole number answers either. Yes, I think it's got itself in a little bit of a knot there, because that one again is quite easily eliminated. Yes. So it's having a bit of problem. It called it scaling of the equations. I've never referred to it as that previously. Okay. All right, let's try this one. Okay. Right, so see if we can. I might start a new page for this one because I just need maximum room. So 3x plus 2y equals 29, and 5x minus 3y equals 7. That's equation 1, and that's equation 2. You don't have to add the equations either. You can take them away. So I'm going to multiply equation 1 by 3 and equation 2 by 2. So we get 9x plus 6y equals 3 9s are 27. 3 9s, 27, 3 2s 87. 10x minus 6y equals 14. We add those, we get 19x equals 7 and 4 is 11, 101. I don't know how that, I don't know that that works out that well either. I think ChatGPT is letting us down here. Let's see what we can okay, I'm not sure about that. I don't think 19 goes into 101. Pretty sure it doesn't. 101 divided by 19 equals 5.35. So that's not one either, unfortunately. So yes, ChatGPT has definitely let us down here. Let's see if we can get it to okay. So it's okay. So this one is double check the solution and right, 2x plus 3y equals 22. Okay, this time, so we'll try 2x plus 3y equals 22, like so, and 3x 2x plus 3y equals 22, and 3x plus 2y equals 21. Whoa, okay, so to eliminate here, how do we do? So I'm going to multiply that one there by 1, multiply that by 1, multiply that by 3. Oh, that's equation 1. We'll multiply that by 3. This is equation 2. My mistake. I'll try and eliminate y here. Try and eliminate y. So I'm going to multiply that by 2, which will mean that will become 6y. And then I'm going to multiply that by 3. Okay, right. So now we get 4x plus 6y equals 44. Multiply that by 2. 9x plus 6y equals 63. Now, what I'm going to do is subtract them. So 4x minus 9x is 5x. You've got to be very careful with the subtractions because you can run into trouble. 6y minus 6y eliminates the y's. 44 minus 63, no, 4 from 13 is 9. Gives us 19. Should be minus 5x. And that doesn't give even numbers either. So we've had a little bit of trouble with that one. Okay. It's a bit disappointing. Because I don't think. Okay. Right. Okay. I just want to get this one done. We're going a little bit over time here on this one, but we will get this one. We'll just check it. Okay. So 3x plus 2y equals 24, and 5x minus 4y equals 4. That's equation 1. That's equation 2. So I'm going to, well, all I'm going to do is multiply equation 1 by 2 and do nothing to equation 2. So that gives me 6x plus 4y equals 48. And then we add them. 11x equals 44. Divide through by 11. X equals 4. When x equals 4, what would be the easiest one to use? Equation 1. 3 times 4 plus 2y equals 24. So we get 2y equals 24 minus 12, which equals 12. We divide through by 2. We get y equals 6. So our solution is 4, 6. So let's check that here. Brackets. Have I got it wrong? Dear me. Having a drum. Three x plus 2y equals 24. 5x minus 4y equals 4. 3x plus 2y equals 24. Three times 4 plus 12. So 3 times 4. 3x plus 2y equals 24. 3 times 4 is 12, plus 2y equals 24, y equals 6. I've done something wrong there. Oh. Oh dear. Now, I've got to sort this out. 6x. Yes, so then I get 11x. Oh. I subtracted them. That was where my mistake is here. Okay. Oh dear. All right. My mistake was here. I get, add them, 11x equals 52. 52 by 11. X equals 4 and 8 over 11. And again, that is not whole numbers. So the solution. So again, that is not whole numbers. I made a little error there, which happens from time to time. Right. Okay, so what it's done there is it said, finally, a genuine, checked and confirmed pair. This does require scaling and both equations to eliminate a variable, and the solution is whole numbers. Triple check this one there. So, yep. So what I'm going to do is I'm going to leave that one. Have a look at it. I think I've sort of demonstrated how to go about it. and we've got some problems there. I've left it in a bit of a tricky situation, but certainly, yeah, we the old Chat GPT not as good as I would have expected on that one. So and I guess we learned from that, and that we can't. We've got to do our checks and things like that. So we'll see how this one comes out. I think one of the things that we can see here is it's not easy making the questions so that you get nice, simple answers. But the nice, simple answers help us to understand. And once it gets, not simple answers, the complexity ramps up pretty quickly. So the big question is, has GPT got it right this time? Let's see what happens, and I'll see you again tomorrow. Apologies for if I've confused or things haven't gone quite as you expect, but from time to time that happens, and it's a matter of picking it up where we left off and learning from our mistakes. And well, one of the things we've learned is not to rely too heavily on AI sometimes with maths. Maybe ChatGPT is not the best one for mathematics. So as I said, this is a live maths, and main purpose is for people to come in with their questions live. So I'd really appreciate that. Don't worry about interrupting me or anything like that. That would be cool. And this has been a Maurieo presentation, recorded live in our lovely little studio in downtown Ngaruawahia. The big smoke in Aotearoa, New Zealand, a place where Kiwis live in a paradise we like to call God's own country. Good night and good gardening to you all.